That was a spontaneous one, just for everyone to know. Thinking, hey, we just do a recording, and then we said, hey, why not doing that live? And I actually forgot how difficult it is to start something spontaneously on LinkedIn. There we are. Hello, everyone.
Howdy.
Okay. We want to talk today about continuous delivery, and that is a part of the current content track I'm doing, because continuous delivery is something extremely important for me, and it is unthinkable for me to not practice it. But when you actually start to talk about continuous delivery, for example, on LinkedIn, I'll just stay on LinkedIn today, you see something very special. There are so many different ideas of what continuous delivery actually is. Some people simply say that is the second part of the CI/CD pipeline. Others say it's all about automation. The next one says it's all about going to production with everything you do. And the next one is saying it is only should have a staging system, something like that. So there are basically some true things and there are some misconceptions. And we want to discuss that today. And this is the reason why I've asked Bryan about that, because Bryan is a main contributor. Can I say that? To Minimum Viable CD?
Yeah, I'm on the core team.
Or core team. So that's actually something very interesting, because feels for me very official now. So we can actually talk about that. That's interesting. And so I would like to ask you some questions about that, but would you like to quickly introduce yourself so that the people listen to it, understand who you are and what you have to do with continuous delivery?
Yes, I'm a software developer. Been doing that for a minute. Actually, I got my first job in 1996. And I was we created a small Tiger team at Walmart to try to figure out continuous delivery back in 2014, 2015. It's been a minute. And learned how to do it by reading the book Continuous Delivery and solving the problem of how do we get today's code into production today in some place where it's never been done before, which was entertaining. And later had the job of helping other teams solve that problem in their context. So their delivery context, their business problem context. Not just, hey, do it the way we did it. It's like, why can't you do it? Let's figure out your problems. Learned a lot doing that. I'm shouty about it because it makes developers' lives better. The morale on my team when we got there, the morale on the teams at my Dojo team at Walmart helped always improved. It didn't even have to get all the way to continuous delivery. Just getting the continuous integration would improve morale on the team. And so I need everybody working that way so I don't risk moving to a position where they don't. And I will say that there's a lot of people who talk about a lot of stuff. I only talk about stuff I do. I promise I won't talk to you about stuff that I either don't do directly or I'm not connected with in some way.
Many people should do so as well, especially in the times of AI, right?
Yeah.
Okay, that's very interesting. So for me, it's like continuous delivery is so important because it feels so natural. So when you work on things in non-development aspects, right, in your normal life, you do that as well in some form of continuous delivery thing. You don't want to really do something like a little bit that, and then you pause and stall the process, and then you continue doing that. Normally, you try to keep things doing so that you get to the finish line, but you want to have some feedback, either if you do something in your garden or not. So it's always like you try to get feedback from what you do. You try to do that, you stay in the flow, and it takes the time that it takes to do it right, and you need to have the feedback to do so. And I think many problems out there with continuous delivery these days is that my biggest problem I see out there is that development and the business, so the two big parts of a typical tech company, they are not on the same page when it comes to the continuous delivery. So that is one of the topics we can discuss today. Continuous delivery when it only is practiced within the development department, for example, if it's a department in that case, or when it's actually done as an entire company, as an entire big team, right? Thinking of not only I make changes to a technical system, I make changes to the product. That includes the business people, the designers, the product owners, those kind of things. And that's one of the interesting aspects. But when I read something like, for example, the first thing, let's start with the false things, right?
Well, there's something you touched on I think is very, very important. It's very difficult to do continuous delivery or even really do CI well if you're not focused on the business problem. If you're only focused on the technical aspects, you're going to struggle because you won't be able to test. Your tests will suck because you won't be testing for the business problem.
That's actually one of those things. That's I hear that often, that developers want to stay for themselves, not being in meetings, want to have their focus time, and then they write their tests, and it's just they test their own functionality, and then no one sees that. And in my opinion, you should talk with other people about test cases, especially on
I,
more complex things.
Here's the thing: is I'm a business expert solving business problems with code, and that should be what developers are doing. If you fall in love with it, I used to rage at people because they'd be so enamored with some technical thing instead of business problem, like, oh, we're going to write our next service in Python because we want to use Python, and that's a real thing that someone actually told me. We want to learn Python, so we're going to write our next, even though most of the stack is in C#. We're going to write our next one in Python because we want to learn Python. That's a bad business decision. That's just dumb. That's poor engineering, and developers should do better.
That's more like a hobby thing. It's like
That,
what
you're
pleases us
playing at
personally.
work. You're just playing. That's not doing your job.
Do something like that as a side business, but not as a primary business, because on some point, so especially when you employ people, that's not responsible how you actually lead a company. And if you are a software developer, you shouldn't do either. And that's one of the reasons why I prefer from time to really say we are software engineers, not primarily programmers, because programmers is so reduced down to a very specific task of sitting in front of a keyboard and doing something. But
So
the engineering part is extremely important to understand. It's because there is so much more to what we do. You just said it. We are business persons solving problems with code.
yeah,
And
be an engineer, not a coder. But anyway, I just want to make sure. I wanted to hammer that home. That you will suck at testing if you don't understand this problem. But anyway, going back to let's go through the questions around
there's
continuous.
so much to talk about that, because CD is so fundamentally important for every development cycle. So we will have some spin-offs in that during that session.
Well, and
Okay,
since CPU is primarily a quality process, not a delivery process, you need to understand the business problem.
I think that's one of the interesting things, that many things out there like TDD or CD often have namings from the beginning, from the initial idea, but it turns out that it oftentimes leads people to think about one specific thing differently as it actually is in the reality. So for example, CD, we have continuous deployment and we have continuous delivery. Something which is pretty weird sometimes for especially people hearing that the first time. And then you have CI CD, and then you have a CI/CD pipeline. I would come to the first point. I was reading on my Substack a comment about a person said that continuous delivery is actually all about automation, and all automation actually isn't a silver bullet, and it doesn't fix all problems. What do you think about that statement?
I used to think when we started, I thought it was just automation. And then I started thinking through the problem like, okay, well, when we're about to automate a process for delivering software right now, there's all these manual steps for delivering software that we do to protect ourselves from staying awake at night. Because, I was learning how to do this on PA risk systems in distribution centers spread across the country. Was it the cloud? That these were high availability systems. Downtime tolerance was 0. Every minute you were down was going to cost $1,500. And so you were going to wake up and you're going to be the one working in the middle of the night. And I'm like, okay, now, geez, we don't even know how to test in an automated fashion. We really have to solve that problem. You start working backwards from this is the engineering problem I have to solve. And suddenly things become very, very clear, Um, and at the beginning, I thought, okay, well, we'll just have to automate everything. By the time we were done, by the time we learned how to, we had, a few teams where the pilot teams were learning how. I was leading one of those teams. And my takeaway then was it was 30% automation. The other 70% was how we work. They're a lot easier now. It's 10% automation.
That's what came to my mind as you just said. It is actually just a fraction. It's definitely not the half of everything. But when you take a look at modern systems, modern platform as a service solutions, which you can just rent from with a credit card, you have so much already provided for you in a best practice way, especially for a startup.
GitHub Actions didn't exist. There was no real good platform tooling out there at the time. We started a platform team that consisted of originally 2 people. One of them was my partner on the Tiger team, and they were building out Jenkins templates as a platform, so the teams didn't have to learn Jenkins. All they had to do was learn how to bring in the template and have a baseline pipeline, and then extend that pipeline as they needed, which is a pattern that I find is the best pattern. Is just I don't need to learn, I don't need to own the tool. Just give me a template I can expand. And That took a lot of work. Jenkins. But yeah, it's so much easier now. I can spin up a pipeline in minutes. Just go to GitHub and do it.
Yeah. So we use, for example, I'm a big fan of DigitalOcean App Platform. I don't know if you know that, but you actually just connect your repository to it and then release it all for you, including services, even serverless if you like. And it's quite great. And it will even become better. And I see many other systems working like that as well. There are in the large cloud providers.
And Netlify is the same way. You just pointed at your repository, you can get serverless functions, and it just automatically deploys everything for you.
Exactly, and you really push it into your. You have then, for example, in the TypeScript space with Node.js, you have then your build command, you have your test command, and that's actually everything in line. And then you might have a post job after deployment for some kind of end-to-end testing, integration testing, and then you can spin it up. And this is actually the automation part. But as you said, it is just a fraction of the part. So to answer the question, I would say that in reality, continuous delivery becomes more and more a set of practices, which is a quality system. It's a system to work maturely and not postpone things into the future.
I think it's important to get into a little bit of the details of why we say it's mostly how you operate and not the automation. Because to do CD, that again, working backwards through the engineering problem, I have to be able to deploy software that I'm confident has been tested correctly. Okay, that means that the pipeline has to contain all of the tests, and it has to do it quickly because I don't want to have a long test flow that delays feedback. It causes all sorts of poor behaviors if your pipeline takes too long. Okay, you won't validate things correctly because you go off and get coffee or a context switch off to something else. You need a short pipeline. So I need a short pipeline, and I need to make sure everything's tested well. That means I have to spend a lot of time focusing on my test design. It also means that any code change I make has to have tests with that code change. I can't bolt it on later. I can't even add it before because it'll possibly break existing code, break the pipeline. It has to be concurrent. Okay, that means I have to have enough information up front to make sure that I have really good tests. That means I can't have vague requirements. I'm going to back up all the way up to requirements refining and be part of that process to make sure that we have testable acceptance criteria coming out of refining so that I can break things down small, so that I can do CI, so that I can have a CD pipeline that's effective. And so when you just work backwards from production, solve those problems. And that's why it's not automation.
We have talked about automation now. So now we have sketched something where we have this typical, we build, so we push to our repository, then something builds, something tests, and then there is a deploy. And that is where there is already confusion out there. So is that deploy production or is that deploy a staging system? What is the minimum part here? And what is what we see out there but is still CD? That is one of the questions I want to solve today. So for example, you have the typical staging system where some automated tests running against, and then some people basically push that direct to production. Some people push that in the night to production. So there is several deploys on staging and once per day to production. Then there are others who even say that we have a staging system, we work on that, and once in a while, but not daily, we deploy to production. So what of that now is actually still CD and what not by its original idea?
So if you think that staging is the final place to go and that's where we're going to get feedback, and you call that CD, that's not CD. But production's where the loop closes, not a lower environment. I've typically, for anything complicated, you're going to do more than just build locally and then deploy to production. You're going to have an environment where you're running more comprehensive tests. This is what the acceptance test phase of continuous delivery. I mean, you have the continuous integration testing phase, which are your really fast tests. And then you have acceptance tests that happen in one or more environments after you've built the artifact and you're testing the artifact. Now, I could run 4 or 5 artifacts down that pipeline and then deploy once a day or once a week. And it's still continuous delivery because I have a tested artifact that can be deployed. And so in theory, you could deploy once a month, once a quarter, and still call it continuous delivery, except that there's the batch size problem. You're trying to get feedback that not only that it tested correctly, but that we're testing the right things, that the idea that we have, the idea we have to solve the problem that we think we're trying to solve is correct. Number one, are we solving the right problem? Cool. Are we solving it the right way? Cool. We don't know until we deliver that to the end user and they give us feedback about whether we solved the right problem more effectively. And the more code change you have piled up, the more the bigger the likelihood is that you've got the wrong solutions in there, even if they test exactly the spec. The spec's wrong. You have to test the spec. You can't do that until you deliver. Now, there's things you can do to mitigate that. I mean, you can't always deliver as frequently as you'd like because of the environment you're in. And my background, I wrote an article today about my background of supply chain software. You have different ways. The way you want to deliver freight through a supply chain is like 0 touch points or as few touch points as possible with no inventory stored anywhere, because inventory is risk. It costs money. But you can't always do that for every kind of supply chain problem. Sometimes you have to batch up inventory because of the supply chain problem we're trying to solve. And it's the same here. If I'm trying to deliver to, we're getting close to the point where I can deliver to a ship at sea. It's mostly a policy issue and not a technology issue. But being able to deliver to an aircraft carrier, destroyer, is something we can do today. We could do CD to an aircraft carrier. Can't do it to a submarine because they're underwater.
You told me about that you are going to try that with.
You can do continuous delivery inside a submarine. But delivering to a submarine from an external source, you have to wait until you surface, and they only do that when they're at port. So they're gone for 3 months. So you have to have a way to deliver to something that's production-like as close as possible that you can get feedback to, and you need actual people playing with it, who are your representative of your intended users, to get that done. It's just not the real feedback. It's as close as you can possibly get. You try to get as confident as you can, but you want to minimize how big that batch is, and so you want to deliver as fast as you possibly can, given the environment you're in.
I saw that in the gaming industry that it was like you had CDs, right? You need to burn CDs or even disc,
so there's
physical media. And there were, in cartridges, there were no patches, no updates. Once it was released, it was the gold thing. And you need to wait for the next version, was the next game, the next iteration of the game. And today, so even in the last years, we saw that you had that from time to time, these updates coming through the platforms. And modern games, I see that way more often, is you constantly have downloads during the day. I just saw that because a colleague recommended it to me. I just installed this Path of Exile 2. I see daily downloads all the time, gigabyte-wise downloads. And that is exactly, that is very interesting. But I saw something what was interesting as well. A developer of another game said, we actually don't want to deploy every time because we want to create hype. That's a strange thing.
But see, this is also the thing. It's marketing, right? If delivery becomes a commodity, people are just used to it, and they might even get bored with the game or not be aware of a new feature of the game. So I get constant updates to the Adobe suite all the time. Photoshop, in Lightroom, and I'm way behind. I can't keep track of all the new cool AI stuff they plugged in to make it trivial to do things like cut out the sky. They've made masking off stuff so incredibly easy, which is amazing. But there's a whole bunch of stuff that I'm not utilizing because I don't know it's there. And so, from a marketing point of view, you may not want to announce the release of this feature. You may soft launch the feature or have the feature off. But from a developer point of view, and I think this goes back to the disconnect between the business and IT about what CD, how often we should deliver. From a developer point of view, I need to get it out in production and make sure that it's not going to break anything. I need to get feedback. Then I need to get feedback from internally. Let's play with it some more in production and make sure there's no weirdness there. Maybe throw it to some beta users and then marketing a launch, right? But those are two separate things. I need to have confidence before I announce something and then it explodes because I didn't deploy it until I announced it.
I think confidence is one of the big things because the interesting thing is to connect it to the beginning where we said that it's actually a way of doing things, continuous delivery. So it's a set of practices. It's a way to operate things. When you operate with constant fear and hesitance, so the lack of confidence, because you actually break things a lot. And stakeholders, clients, and users are not happy about that, let's say. So those things will actually stack up. And on some point in time, you will try to not do any features anymore. In
Yeah,
many companies, we see that with branches, right?
this goes back to the inventory problem I was talking about. Every line of code delta is inventory risk. I used to work for a large global retailer, and they had so little confidence in code change just overall, not necessarily individual areas, but just overall, that they would lock down code change except for VP approval from October into the middle of January. All of that code change landed, and it would destabilize everything and then spend the next month stabilizing because they weren't getting feedback fast enough that they had some sort of issue because they were holding on to that code change.
And then you have the large batch size again. So you have too many things at the same time hitting production, and you can't handle that. One part of the confidence is when you just deploy something small and something happen about that, there is not big of an impact. Maybe in even especially in the business to business area, oftentimes the first client already reports that to you, something like that. So you can immediately act and push in the next minutes a fix out of that. Right, that's possible.
It's a
So
vicious cycle too, because number one, when all that code change lands and things become unstable, you don't stabilize the system during an 8-hour day. You stay up. You work long hours, you work weekends, you stabilize the system because you're talking billions of dollars at risk, which causes burnout, which causes more mistakes. It also causes lack of trust in the business, which means we're going to do it again next year.
So,
and the cycle just continues because you don't fix root cause. I wrote an article several years ago called, I've got a blog, the 5-Minute DevOps blog, and I had the holiday edition. And the conclusion I came to was that if you're going to have code freeze, sure, have code freeze, but stop working on features during that entire time and only work on why you have code freeze, or send all the developers home and pay them for 3 months. That way, at least they won't be generating inventory risk.
I know that's the end-on-code principle in some way. So you really need to say, okay, we need to stop, we need to fix that problem so that we are basically in the continuous flow again. And that is when you work with CD in a team, then you know why that is the case. Because sometimes we had that in another discussion with Dennis today. You have that change you made to the system. So you push something to the system and or someone else is taking over your code because of circumstances. Then you want to be sure that the code which was produced already is releasable. That is the importance of the releasable state or the deployable state. Because you don't want to think about, is that actually something we can do? And when you are in continuous delivery, we're talking about a handful of changes at best, right? So it is not a big PR or something like that where you need to spend a day with some people to figure out if that actually works or not. You have a very small change very often, and you can be very confident that this won't break anything because everyone who is actually working in that way is very mature and is saying, I won't push anything which breaks the system.
In the world, and this is something I hear all the time, it's like, when the real world, I have a friend of mine who used to be a VP at Nordstrom's, which, if you're not familiar with Nordstrom's, it's a pretty big high-end store. Okay, they're all over the states. I don't know if they're out external states. Anyway, she's a VP at Nordstrom's, and she was piloting for Nordstrom Ecom continuous delivery. And it's a big retailer. They've got the same blackout dates that companies like Walmart have, right? I mean, you've got, you want to ship on Christmas, you don't want to ship on Black Friday, the day after Thanksgiving. You've got these dates where people are terrified to ship because it might impact sales. She and her team got so good that they had a waiver. They had no blackout dates. They could ship on demand whenever they wanted to. And this was 2014. She was one of the very first people I talked to at DevOps Enterprise Summit when I attended for the first time. And all it takes is the discipline to clean up your mess and build that kind of quality.
Yeah, that's actually one of the things. And I think the hesitance is that, or why people have problems to start to think about CD deeply, is that what you just said, for many, is just a theory. What people really see in their companies is that there's this finger pointing going on where the business people, the users are always saying, but please this time make sure nothing breaks. So you already get that idea of, hey, people think we are incompetent while we're doing things.
That goes back to the 10% tools and 90% how we work. It's also relationship rebuilding, right? When you're on this journey, if you haven't started this way, you're gonna have to rebuild relationships and get people on board and just build a team of teams, across boundary lines that this will work. Which, by the way, is why DevOps is a thing. That's what DevOps is. DevOps
Original
isn't
meaning of the
somebody building
culture.
pipelines. Isn't someone configuring pipelines for a product team. That's not DevOps. DevOps is how the entire organization aligns and delivers value.
Yeah, the united ownership, and not the administrator ops person who's called DevOps today by the recruiters. It's a little bit like a big misunderstanding. We have a comment from Sanjeev. I would like to go over it. Let's quickly take a look. What I have also realized is that the more we deploy into production and in small sizes, the confidence starts rising. I will be organically more confident where I deploy at least once a day versus once a week or more. What do you think about that?
I agree, but more than that, delivering is fun, and you get a chemical hit in your brain every time you deliver. It becomes addictive.
Especially when you push the button and you don't take a look at your pipeline and your production because you know everything is working for you. If it's going through, it's working.
My company takes a 2-week hiatus over the holiday because our core business also there's not going to be any work getting done during those 2 weeks. So to refresh, the company's made the decision to send everybody home for 2 weeks. It doesn't count against your vacation, by the way. And on the Friday before we left, one of my teammates made a change, and I deployed it at like 5:10 p.m. And then went on LinkedIn and said, I just deployed just before my 2-week break. See you guys in 2 weeks.
Mm-hmm.
And I did that to brag a little bit and to show that it's not something you need to do. But if you're scared to deploy on Fridays, I'm not saying everybody has to go and deploy on Fridays, right? I mean, that's not even the entire point of the conversation. The point of the conversation around Friday deploy is that if you're afraid to, you have problems that you should fix, right? And so it's not wise to deploy on Friday. It's not wise for you to deploy on Friday because your quality sucks. If you're scared to deploy on Friday, why aren't you scared to deploy in the middle of the night when it's really important?
Exactly. What happens if it's really problematic on the weekend or something like that? Then you actually are not afraid. You are still afraid to deploy something you were afraid of already on Friday to deploy. And I don't like to go into the weekend and think on Monday then, oh, I need to deploy what was on Friday, but what was it again? And there were so many changes. I was afraid. Can we actually do that today? We have already new changes. What is better on Monday? So if you need to be there for every deploy, that is recipe for burnout, to be honest.
Well,
really.
There's one other thing that I think is important. If you're doing CD, you have one way to deliver any kind of change, which means that the safest thing for you to do on a system that requires high uptime is to deploy on Friday so that you have a clean pipeline in case something breaks. To remove the uncertainty of the inventory backed up in your pipeline. So you have a clean pipeline to start with so that if something breaks, you can deploy change and know that you're only deploying that small change instead of trying to do some sort of hacky workaround to deliver a hotfix.
Yes, and you have the possibility to roll back anyway in a good system. So if you see that something is bad, you just click rollback and you are in some systems in 10 seconds back online with the older version. But you don't have to if you don't deploy.
Deploying to Metal, to HP PA-RISC systems, a decade ago. It's so much easier now.
It is. So it is really what modern cloud or even good platform engineering teams are providing is great. It is like you can, as a developer, really focus on what you need to do is getting things out, thinking about business, thinking about changes, thinking about why are we going to do that? How is it working? How do users perceive it or something like that? You don't need to take a look. Will it actually deploy? So just technically, that is not a big of an issue these days. And I saw the bad examples out there. Pipelines where people say, I don't want to have GitHub Actions or some built-in pipelines because we need to have very special pipelines. There are so many things going on in that pipeline, right? Like people using 5 testing tools for integration tests, component tests, and unit tests, and thinking to myself, why do you make it so complicated for you? You don't need to have that complicated. And
if people would just read what's the simplest possible solution. I'm not going to go use Selenium because I can test the front end with any of pick your JUnit, I mean your XUnit framework for JavaScript, if you like. I can fully test the front end with that.
So, for example, we had that discussion today as well. We use Cypress for testing, so we can do unit tests, we can do component tests, we can do integration and end-to-end tests. This is what we can do. We don't want to have 5 suits because we need to maintain those. We need to make sure everyone understands those. We need to make sure we mitigate and update those. But we only have one, and that is quite easy to do. So keep the thing simple, even though there might be a better solution for a very specific thing, we still tend to make it easy, and they are still good. So it's not like,
I was having a conversation about BDD and Gherkin a couple days ago, and someone asked about Cucumber to parse it, and I said, yeah, I've tried Cucumber, and there's things like SpecFlow out there, but BDD is a process, it's not tools, and you don't need tools that are specialized for BDD. You just use your XUnit framework, whatever it is, and write the tests that way. And like, just keep it simple. You don't want to have multiple tools that you're having to play with all the time. Make mistakes. There was one team I was on where we had Java on the back end and we had Angular on the front end. And which meant that I had a front end group and a back end group all on the same team, which was annoying. And there was no performance reason why we needed Java. And so the team switched over to Node on the back end so that we would all speak the same language.
I really prefer that. I don't understand all these, especially for startups. So companies should really depend on it must work, right? We need to create value, otherwise we die as a company. So pick that. Hey, we need to have the most performant back-end language and environment, and in the front end we have a totally different one, but we have only 2 different. So that's not the best thing. So just use. I'm personally saying always for small startups, that's actually in the last video as well as a little thing, is always go for JavaScript first. If you have the specific need that JavaScript will become too slow for you, it is very unlikely if you just build an app out there.
And also, if you're focused on small services, then you might have this service that needs to be rewritten in a new stack.
That's the point.
And in fact, when we started doing that, we wrote a JavaScript service that went along with our Java services to see if that was a good idea. We started with the next, we needed a new service for a thing. We could keep it small and cohesive. So we tried it in script because we knew that if we needed to, we could flip it over to Java in a few days. And having the ability to have different languages based off of need.
We have to as well. And actually, we did that, but we actually never did that, which means that we have still everything in JavaScript. It turned out that with modern caching technologies and all these kind of things are fast anyway. So it is not like, hey, your things are so slow because you use JavaScript. That's not true. And it's not about JavaScript in particular. It's about that JavaScript is widely adopted, widely understood in the market. So it's easy to find people. It is not a hard to understand language. And it is quite easy to use the full stack approach again, or at least having that, we talked about that, the DevOps idea, so that you have everything in one team and everything is working together. Everyone can review the code of other people, talk with things. And it's not like, for example, if you take Rust and JavaScript, it is very unfamiliar languages. It is a very different concept behind that. You can do that. It does work. But
and pull it back to continuous delivery. I used to have the thought that every team should use whatever language they liked. And then I moved to platform and realized that there's a cost for every single language in your organization's stack. And so what you should do is you should use the minimum set of languages so that you can have a lean platform that's stable for the entire organization.
Interestingly, we are both active on LinkedIn. When you look at LinkedIn, that stance is not widely adopted. So you see very much about people talking about the technical nitty-gritty geeky things. It's like, hey, we need to use Rust because it's so fast. We need to use Go because it's so great to work in. And the point is that people often misunderstand that it is not the single component which makes the app. It's the overall thing. And it's the business aspects. How much does it...
environment. We had, like, when I worked on platform at Walmart, Python was a niche thing that only some of the data scientists use. And then teams wanted to use Python. We served Pi off of an old Dell computer under somebody's desk. It was not a core component of our platform.
Mhm.
It's like your guys are going to struggle because you're choosing, you're making tool selections based off of personal preference instead of what's well supported in the enterprise. It's dumb, so dumb.
Yeah. And one thing as well. So just to build up on that, when you take a look at things like state of JS and those kind of things right now, that wide adoption. So you always should stay close. And that's another thing I really appreciate is stay close to what is industry standard. Don't try to find that's the new interesting new thing. I just saw that coming out. It's there right now, so we use it because it's fancy. No, don't do that. Stay with
Yeah,
what is solid in the market. That is important.
there was a team that was so proud of their closure. They'd written everything in closure. Cool, bro.
Yeah. There's a reason why we don't build and assemble things anymore, isn't it? There is a reason, a slight one. Yeah, there are still people doing that, but you shouldn't. It's like, yeah, you could build your own browser, right? You can't do that. Well,
Keep it simple. Stupid.
KISS principle. It applies so often, and so there might be reasons. As you said, the service-orientated architectures, somehow in the last 1 year, the service-orientated architectures or microservice or something like that, this is the reason why I tend to call it services right now, because people totally misunderstand these topics and how powerful they actually are. They always think of the original definition of the microservice thing, which is a standalone by own team and all those kind of things. But if you take a look at your own application, you have at least a front-end application, right? Somewhere, something React, for example, in Next.js or something like that. In your case, Svelte. And you have at least one service. But most of the times, you would have the need to already have one service for the main app and one for the creation of PDFs and the next for whatever, right? So that is already a service. It's not a microservice per definition, but that kind of architecture is still maintainable in one repository, in basically a mono repository.
From a continuous delivery perspective, it's so much easier to test if, number one, you understand domain-driven design and have clean domains, very deliberate about your domains, and break them down to the right level. I can focus on this one core concept that I should be able to design. I have to design my tests so that I can deploy this one service independently of any other service at any time in any sequence, right? I mean, there's engineering problems that you have to focus on around you design for delivery. This is the other thing CD makes you do is you design for delivery. And now I have super high confidence because I don't have to have a big end-to-end test because we've designed for testing. We've designed to have unentangled domains. Somebody asked me earlier today about, if you find that you have emergent properties from the system, I'm like, well, that's a defect. I don't need emergent properties from the system. I would go and track down why I have that. And instead of writing a test for the emergent property, I would fix the entanglement in the domain so I don't have that emergent property anymore. Yes. It's like you design for delivery, you design for testing, and that's what CD makes you do, because you start putting time limits around pipelines as a forcing function on improving architecture.
Mm-hmm. Mm-hmm. And yeah, that's a very good point. And the point you said beforehand as well with the architectural aspects. So we have that as well with the ports and adapter pattern. And if you go to a team and you try to tell them, hey, the ports and adapter pattern is actually a good idea, and the response you get is that takes too much time, then you know they have a problem in the development cycle and architecture, because that leads to a very bad system which you don't want to deploy on Friday because you don't know what happens because nothing is tested.
Definitely don't want to tell a VP it's going to take us 4 hours to deliver the change after we make a fix at 3 a.m.
Yeah, that's because that's a typical system. In the worst case scenarios, you deploy something, then you need to deploy a fix, and then you need to deploy a fix for a fix, and then you find out why other things are not working anymore. And that is exactly when CD is not only about how you actually get your change from to, but how, right? How do you design that you don't have these obstacles in the way? And you said that in the beginning, which wasn't recorded, is like the book Modern Software Development by
Software Engineering.
Software Engineering, sorry, by Dave Farley. It is so important to read books like that, right? Because they describe it in somewhat good detail. Why we should think about those things. So I only can recommend to do so, right? This is not the only book, but it is one of the books which is pretty good wrapped together. So especially around this topic, right?
Oh man, I wish I'd had that book when I started. And I really wish it was required reading before anybody got a job as a professional developer.
It is on point. It is not so abstract like most other books are. So you need many books. You really need to understand the concepts behind it on an abstract level. And that book is so great because it is so close to the actual on the hands-on work, understand that in the perspective of a developer. And you should, on some point, you need to understand how, as a beginner developer or someone who has problem to understand the basic concepts of software development, you need to find ways to get as soon as possible to the state where you can work in an environment where you can actually contribute positively. So net positively. So you don't want to be that person who is causing problems and hiding away the work. And that is one concept of so not a concept, but when I think of CD, there are so many good resources. You are out there, Dave is out there, minimum viable CD. There's so much to take a look at. But one of two core aspects is, first of all, the business aspect is not discussed enough so far, and the aspect that you as a software engineer need to be on a mature level, and you should have a process which I call the average developer approach. You shouldn't design a process which is only basically changeable or usable, or let's say you are able to participate as a senior. It must be that the average intermediate developer needs to be able to participate in every step, and juniors shouldn't be confused. That is important.
That's the other thing. It's like, oh, you need a really good team to do continuous delivery. Yeah, but you don't need to start with a really good team to do continuous delivery. And I know that for a fact because of how many teams, including the very first one where I didn't know how to do it, how we've gotten to that level. I wrote a blog post several years ago about the journey from going to the things that you will probably see, because we saw them going from quarterly to daily or faster delivery. And, it's literally like lifting up the rug and seeing all the things that people have been sweeping under the rug, and you have to go and fix all those things, right? But the very first team that I learned how to do CD on, when there was 50 people, we had a product owner, a business analyst, and then 13 developers. Some of those developers had senior titles, but not senior capability. Some of those developers had just gotten out of college and, frankly, were not cut out to be developers and were not good. But we had a process in place where we could deliver high quality of how we worked because of the detail we went into about breaking down, focusing on testing, honestly. It was just that because we were focusing so heavily on testing, we would have inside our team, we had 7 services inside just our team. We didn't have one service we owned. And we had, anytime we make a change to one of those services, that the task that you'd pick up, and anybody can pick up any task. This is so important because that distributes the knowledge. But the reason anybody can pick up any task is because these are the behavior tests that it should pass. And here's the contract test changes you have to make. And that everything was communicated as tests. And so that team grew into the ability to do continuous delivery. Now, a couple of the developers who shouldn't have been developers never really got to be really decent developers, and we use them for other things mostly, but it elevated everybody.
Coffee needs to be done as well, right?
I mean, you've got, external communication to help with. You've got, help with UX design.
That's a typical developer with 3 years of experience doing all day long end-to-end tests for others.
We didn't have any end-to-end tests. And we had no manual testing at all. In fact, we had a testing team in Chennai assigned to us. I think it was Infosys or Cognizant or one of those companies. And we very quickly surpassed their ability to test and fired them off my team.
Actually, it came up right now with the last bit of the discussion are blocking pull requests and code reviews a part of continuous delivery or not? What I mean by that is we know that from things like Git flow, where you actually need to wait until X people have reviewed the code and say, yeah, you are allowed to deploy that or escalate it any further. How are pull requests and code reviews seen in continuous delivery when you only have one branch?
So it very much depends. All right, so number one, if you look at the definition of continuous integration, you need to be doing trunk-based development. But if you look at the definition of trunk-based development, it doesn't mean you only ever have one branch. It just means that those branches are very short-lived. And continuous integration will tell you that it's going to last less than a day. So how do you do code review? So I have only ever worked in regulated environments. Before I had SOX regulations I had to deal with. Now the stuff my company works on, we're dealing with the DoD, which is a whole bunch of NIST regulations or NIST compliance. We use code review, or actually we use the mechanics of a get pull request to meet some of those compliance standards. Okay, the way we do on my team, we sometimes pair, we sometimes don't. It just depends what we're working on at the moment. It's really hard for me to pin down a period of time during a day where I can pair because I'm doing other things. But when we do code review, we do code review as soon as possible and pair on the code review. We never do async code review unless it's Amber's like, hey, I just submitted a pull request, and then I wake up early in the morning and I review it because she's not up yet because she lives on a different time zone. And so it's as soon as possible. Now, if you're pairing, you don't need the pull request. Or code review is instant. If you work in a regulated environment, I would still use a pull request just so I have the documentation of you pulled my pull request while we paired on where I was driving. And so I'll drive, you navigate, then you submit my pull request and we'll change and we'll go on to the next thing. Right. And you just need to focus on continuous integration. If people want to use, I was on I had a presentation I gave last week for a small group, and I made the comment that I don't care about trunk-based development. I just don't care at all. You can use GitFlow. I don't care, as long as you're doing continuous integration. So if you want to use GitFlow and do all of those merges, you can just make sure you do that at least daily, preferably more frequently than that.
I never saw companies doing that, actually. It's more like we try to close it in the next weeks. It's a little bit like that. Hopefully after vacation of that single person.
But if you're not doing CI, you're not doing CD straight up.
Yeah. So it's a good point. So in the startup area, small tech or traditional area, which is non-regulated, so there are the smaller companies, let's say...
If you can push straight to trunk and then do code review after and feel confident about it, you should do that.
I like to tend to say even that in a mature environment where engineers feel like engineers, you actually know when to ask for a review. If I need to change a headline, I don't ask for a review. If I change something which interacts with other systems, especially features owned by maybe someone else at the moment, right? I want to talk to that people, right? For example, there are backend people who are more focused on the database parts, GraphQL, those kind of things, and that is the front-end area, and we have a change which does affect the interfaces in between. Then I like to talk to the people. I tend to say, hey, do you have 5 minutes? I want to talk about that. And I hate it when I see people out there saying, oh, don't interrupt developers. They need to have their time for themselves. Why? So it's not like, it's not like you are sitting on the toilet for yourself. It's a little bit like you are working on a common project and you need to work together. So if someone needs to have help to actually progress correctly, then just give that 5 minutes. It doesn't pull you out of any form of context. If you can't keep your context after 5 minutes of interruption, or if it's not a bad interruption, then you might be not suited for the job in general. So I don't think that's
working correctly. You're working on related stuff anyway because you're all focused on the same feature.
Exactly. That's why I love so much the idea of monotasking, or at least only what is actually on the table, what you actually can do in 1 day or 1 or 2 days. Do that as a team. Get it. That actually is quite compatible with the idea of if the pipeline goes red, if we have a problem as a team, we stop, we fix the problem, we share the knowledge, why that happens.
And so this is an important team behavior that I've had lots of people push back on because, well, I can go fix it, I'm going to keep working. You're building up a backlog of work that you can't verify. You can't deliver it. You can't test it. So the most important thing for you to do is to clean that pipeline.
Yep.
And because otherwise you can't do your work. What are you talking about? I'm going to sit here and code. You can't validate it. You can validate it locally, but works on my machine? Really? That's what you're going to tell me?
I think the typical environments which try to avoid deploys, which try to hide things in branches, very long-lived branches, right? And have some very postponed reviews of those branches until everyone forgets the context and just signs it or something like that. That's a typical area where that happens.
This is like physics. What's the definition of work in physics, right? You inject energy and then some sort of motion occurs. right? In software, work doesn't happen until you publish to production. Everything before that's just injecting energy, right? And so if I'm sitting here on a long-lived branch working, I'm not working, I'm just expending energy. And one of my favorite things used to be to go and troll GitHub at Walmart and see how many branches we had out there that were a month or two old, that were so far out of date they couldn't be merged. That was just expended energy. That wasn't work. Someone got paid to expend that energy.
Thanks, Sanjeev. We are happy that it was a nice thing for you. Actually, it's always great to talk to Dave. We've talked about Dave too much today. Of course. Sorry. Okay. No, it is so interesting to speak with people who are actually know exactly what continuous delivery is. Not for the sake of it must be CD, it must follow some kind of religious thing like modern capital A agile. It is like what we need to understand how it actually works, what common sense is, and how you can actually get the business to run. And that is it is so important to understand that we are all business people, so that we are part of a business. And I was basically starting my career not directly in the IT or software development in general. I was doing software development, but not professionally. And I was more in a more traditional company, which was creating stuff. And they had already that in mind. They were everyone is just participating on, I built or I craft something today and it will be delivered in the evening. And they all had that mindset already. And why was it in the software development space so hard to understand this little concept of let's get something done and deliver it today and get some feedback how it is so we can make it better tomorrow, and not waiting for we build now thousands of these things and at some point in time we go out there. There's another example. There's this famous, I think it's famous, this test at a university where people need to get a perfect shot, the perfect photo. There are two groups. The first group is basically doing a lot of shots to try to get to the best, and the others are really preparing for the best shot. They only have, 10 shots and must work, and the others had 100 shots. And of course, the people with basically doing shots every day got better every day and had the better shot because they worked towards it, and the others basically gambled maybe they have a good shot or not. And that is what actually happens in the software development space as well. We need to get to the point to understand what is actually what we want to build. We don't know that on day one.
That's something else I was talking about today about testing, about how we architect our entire test strategy around 3 o'clock in the morning. That we design everything, including the application, for 3 o'clock in the morning delivery. And then all we're doing daily is practicing for that. And then when it does break, it's habit. It's muscle memory. We know exactly where to look. We know exactly how to deliver that change and make sure that we have a lot of confidence it's not going to break anything. It's just muscle memory. We always work the same way. I've got a blog post where I talk about it's the only metric that matters. And it's got a series of photos where I went to Nellis Air Force Base on a Tuesday. It wasn't an air show, and watched the Thunderbirds practice. And they did the same thing the same way that they do at an air show, including what they do when one of the airplanes was down-checked and failed pre-flight. And so they had to launch the commander on a different airplane. But it was just routine. So they practice for the mission. And the mission is making sure we're up, not look how cool this next feature is. Because nobody cares if you're not up.
That is so important, why we often need to take a look and say software development isn't that unique. Software development is what a human is doing in order to create something new and better over time. And we should have the same practices as we see it in so many other places which are successful like that. And too often software development is treated like something very magical, very hidden away. Why?
Crazy too, because all the things that those other people do is easier with software. It's easier to do these things with software. It's easier to repair a poor design. It's easier to do everything. It's easier to be resilient with software than it is with hardware. Everything's easier, and so people just don't bother.
Try to fix a constructed house which does have a humidity problem because you have made a mistake in the planning, and try to get that out, right? In software development, you're just refactoring things, and you maybe change a design or something like that, and you have some testers, you make hypotheses, you test, maybe even you test different versions of that and take the best one in some iterations. With a house, it's hard. It's
Yeah.
with everything. With a released product, like the car manufacturers, they need to recall cars and really have a complicated process to fix something.
My case, and this is a Peak Design phone case, right? And Peak Design released the original version of this phone case with a design defect. And all you had to do, they had to go and remanufacture the phones. They created a workaround kit that you could get, and then ship everybody who ordered the phone case a new phone case.
Mhm.
Right? The software's trivial, but people don't design for anything other than I'm finishing this feature, I go to the next feature. A lot of people. Then you wind up with the test mafia saying, well, that's why you need testers to deeply.
The test mafia. That's great. You should write a book about that one. The test mafia.
And automation's not testing.
There's they implement test religion. That's more like developers shouldn't test. They are too stupid for that. Please let it be the test professionals who does have a system and everything in place to take over and stealth the process, right? Very important. Don't deploy. Test it. It's about testing, right? We earn money with testing. And this is so stupid. I'm sorry.
Now, this is the very first aha moment I had. I think it was at least an early aha moment about continuous delivery. Is that this is actually about quality. This is about testing. Later on, you start working through. You start thinking about these things longer and longer, and then you go, oh, I'm testing the idea. I'm not even testing the code. I'm testing everything. I went to actually, before we had centralized the platform at Walmart, and before they told me to start a dojo to help teams with continuous delivery, I went to the head of quality engineering and told her that she should hire me to drive continuous delivery across the organization, because this was a quality initiative, not a delivery initiative, not a coding thing. This is a quality thing.
Yeah, imagine if you are in a more traditional company right now where you craft things and you have these people who are about to decide about quality and everyone else is doing what? So how can you actually imagine that the crafting people, the craftsmen themselves, that they cannot decide if something is good or not? That doesn't make sense, because that is where you decide with every step what is actually going to happen. So that is where you need to improve, not later.
This comes back to the siloing. I had somebody from the testing mafia today telling me that how strange it was that I would expect developers to test, but we don't even expect them to refine work or do design. I'm like, what do you mean? Of course I expect them to do that. How do you understand what you're delivering if you're not part of the process of refining the work and designing how it's gonna function? You don't just say it's code. Job is understanding the problem we're trying to solve and solving it. That's the job. That means that you own it all, buddy.
It's actually easy to understand, but it's somehow, you have that already in so many companies. Like, you can't let the developers talk to the customers. That's going to be
right. We got to protect the customer.
So who are you actually protecting who from, right? That's a little bit like it doesn't work. So we should be really in that moment should be thinking about, what are we actually doing there? What is our job? Why we are here? And what is our team? So oftentimes we think we have a team of 3 developers and there is a team leader and that's it. That's my world. It's not. If you're thinking like that, you might be well suited in an open source project, but not in a real project out there, which is creating salaries, creating outcomes to actually be sustainable.
And somebody asked me about the intersection of open source and CD, and there is none. Those are completely different workflows. CD, we have a trusted team working on a cohesive list, cohesive product that's the direction you're trying to go. You're working together as a team to get there. You're trying to get feedback as rapidly as possible. Open source depends on a whole bunch of free resources that you don't trust. And I've had a lot of people, and when I was working in the dojo, say, well, this is what open source does. I'm like, you're getting paid. Open source is the most expensive flow that you can use to deliver software. And it only works because the labor is free and you don't have any timeline. And it works for that because you're asking for volunteers. But if you're developing professionally, you should use continuous delivery. And it's something we talked about before we started recording. Until somebody shows me a better way. And then I'm going to change. I'm not going to sit here and talk about how continuous delivery is the religion you should follow when there's something better out there. I'm like, oh no, I'm going to change to something better, which is very different from many people I interact with who say there's only one way to do things because this is my religion. I've actually measured it. Have you?
CD not really a product out there. CD is more like a common sense practice where you have a lot of other practices where a business system is behind that, like modern day agile, Scrum, those kind of things. There is a business model behind that. And that is one of the problems. I think, first of all, I don't like that. The second thing is it doesn't work. And it is a bubble in itself. So it tries to sell itself, right? And those kind of things actually aren't very good. So you should have something which is common sense or comes down to human common sense. And
Well, I'll tell you
CD is
though
the
that
closest.
I don't, common sense worries me because there's a lot of things that when you actually dig into it, what seems like common sense isn't the right answer. Okay. Of course, it's common sense you'd never deliver on a Friday. Of course, it's common sense that we'd finish a feature before we deliver it. These make sense. One of the problems with continuous delivery when you try to get people started is it's not intuitive because that's not how we've been trained. That's not how we think about the world. It's just not intuitive. And because it's software, it's more malleable than the rest of the world. It's when people try to compare it to this case, right? You can't deliver this case in small increments, but you can software. And so it isn't common sense until you get over the hump and understand what it is. When you really understand what it is you're trying to do, and I'm working on a blog post about this, about the supply chain of information. And what we're trying to do is we're trying to optimize our supply chain of information is what we're trying to do. None of the solutions make sense unless you understand the problem. And so how do we better communicate the problem we're trying to solve so it becomes common sense?
That's a good point. That's what we just said before, that the devs need to be connected to the actual outside problems because those are the problems you're working for or you work out the solutions for. And you need to have the direct feedback to actually increase and improve and change, because everything in the beginning is a hypothesis. Even though you might not think about it that way, it is a hypothesis, and you either prove it and you need to live with the result or actually act on a result and improve it. That's your job, right? And
You know, and so many people get wrapped up in that their idea is good. It's not a hypothesis, it's my idea and it's gold. Or that the code I wrote is amazing because I wrote it. I got the best compliment from Amber, one of my teammates, last week because she also reports to me. So we were having our one-on-one, and she gave me I asked her if there's anything I could do to improve. How can I help get better at mentoring? And she said I was doing a great job, but she also said that she really appreciated the fact that our focus on outcomes makes it so easy for her to throw code away. And she's been a developer for less than a year. How many developers will just throw code away and just not worry about it? They'll stress over it. No, my code's good. We'll just keep it.
they keep it
Just
like an
throw it
asset.
away. It's garbage if it doesn't meet the need.
It's
Just throw it
liability.
away.
It's liability. They're still there. Everyone thinks about that, and even especially when it's there and running.
The
So no
code
one
is not
actually
running.
knows. Is it actually? This is one of the big problems with CSS out there. Is when you use it plainly, is in so many projects a big liability in the beginning, in the end, because you don't know what's actually still there viably or not. Can I remove it or not? And that is
Yeah.
something which burns out many people because they don't try to touch, especially in the CSS area, they don't try to touch those things because they can't really test it properly. It is like, oh, I don't know. And you should remove things in the moment you understand that you can remove that part, remove it, because later on another person might not understand that, and this is not helpful. You need to clean up more often than you actually add things. So if you constantly add things and you have metrics for that, you can use something like a code scene or something like that, where you get a static code analysis, where you get metrics, how many things you actually add and how much you remove. So
Well,
how complex does your stuff get?
this
Right?
is so important to outcomes because only the outcomes matter. The code doesn't matter at all. If I can solve if I can solve the problem with no code or by deleting code, I'm going to do that. And then also, if your code is hard to change, then your outcomes are harder to achieve. So what are you doing all the time. This is also part of continuous delivery because I need to keep things malleable. I need to make it easy to make change. I design everything to make it easy to make change. I'm constantly looking at the code and trying to find what can we make slightly easier to make it changeable. And so it just takes less work to get it done.
Okay, I totally agree. And sometimes when I work hands-on myself, sometimes I find components which are older. At another age, you really see that in the moment. It's like, we don't actually develop like that anymore as a team. And you think, oh, I need to make a change to that component. And then in that moment, you think, with just some more minutes, I can rebuild that component to a style which everyone understands, even the juniors, and you can actually work from that. You can make easy changes. That one is very complicated to change. Mental overhead is high. Remove it, because that is garbage. That was okay to some time, but now it's time to actually do something about that. And that is extremely important to keep maintenance. That's is not just a phrase. It's a very important NFR. You should be about that, right? And you should work on that constantly. If you cannot read something, or as a developer, you read a function, a method, a class, or whatever, and you need to read several times through it to understand what happens, change it. It's wrong.
We're doing that all the time. We will come across code that was early code that had been written, and we're like, yeah, that's too complex. Let's break this up. It's going to cause an error. It's going to cause a mistake. It's problems. Yeah.
Actually, I need to wrap up. I'm a little bit over time already. It was a great conversation.
Go back to trying to fix a Tailwind problem. We should have talked a little bit about Tailwind and how they made massive breaking change very hard to do CD.
I was trying to skip that one, but not skipping that one, but I still need to go into that one. Looking forward to that. So if you like, we can have a conversation about that tomorrow.
Sorry?
If you like, we can have a conversation about that tomorrow.
Sure.
If you need. Okay.
Yeah, no. If we don't get it fixed today, I'll probably hit you up, see if you have any ideas.
Just tell me. Okay.
Try doing a test upgrade from 3 to 4. You'll love it.
I actually could do that. It would be interesting. Okay, cool. Thank you so much for that conversation. It will be, I will basically put that on my blog as well, so people can rewatch it and stuff like that. Very interesting again. And I hope that it was helpful to the people who were listening. And any last words? How can people reach you? What are your blogs and stuff like that?
So there's on Medium. If you go to blog.berlin, will take you to my Medium blog. And of course, minimumcd.org is our project. You can contribute to that. If you want to add some details, flesh stuff out, if you want to do a translation, because we're translating, I forget how many languages we're translated into right now, but we have several, including Texan, because Texas is a whole other country. And let's see, also my scaling framework. If you want to scale, if you're a large enterprise wanting to scale Agile, then what you need is the Scaled Agile DevOps Maturity Framework. So if you go to sadmf.com, I promise it gives you all of the outcomes of more popular scaling frameworks at a much lower price point.
I would be interested in looking at that as well. Take a look at that. Good. Thank you, everyone. See us then. Probably next week. That will be the last show for this week. We see us next week then. And have a nice evening for me, or a nice day for everyone else who's actually starting right now. Goodbye, everyone.
Thanks, Adrian.